Hello and welcome to this third lesson in the topic on metals and non-metals. In the previous two lessons we've looked at the properties of metals and non-metals and said what makes an element a metal and what makes an element a non-metal. And then in the previous lesson we looked at oxidation. In today's lesson we're going to be looking at metals and how they react with acids. So in your book I would like you to write the title Metals and Acids as you would do for any other lesson. By the end of this lesson you should be able to recall the test for hydrogen gas, you should be able to compare the reactions of different metals with acids, and you should be able to use word equations to show the reaction between a metal and an acid. So if we go here first onto our blackboard, and before I write anything I want to add an image. Okay, and these images are all found on the PowerPoint, so you can have a closer look at them if you wish. What we've got in this image is a picture of magnesium ribbon reacting with hydrochloric acid. When it reacts with hydrochloric acid we get lots of bubbles produced, and these bubbles are a particular gas. So we can start by writing in our books that when a metal is placed in an acid, lots of bubbles are produced. Okay. Now, magnesium, for example, reacts vigorously with the acid. This is magnesium, and as you can see, there's lots of bubbles produced, and we say that it reacts vigorously. What we mean by vigorously is that it reacts a lot, it reacts violently. Okay? So we can say that magnesium reacts vigorously violently or a lot, they all mean the same thing, with hydrochloric acid. Okay, so when we place a metal in an acid, lots of bubbles are produced. Magnesium reacts vigorously or violently or a lot with the hydrochloric acid. Now, we can write a word equation to show how metals react with acid. So I would like you to put the subheading, please, general word equation for metals reacting with acids. Dot dot. So when a metal reacts with an acid, our reactants are the metal and the acid. Okay, we say that these are our reactants. These are what we're adding together in the reaction. So we can put underneath here that these are our reactants. We then add an arrow. Remember, we never use an equal sign, we always add an arrow. And this will always make what's known as a salt, and a hydrogen gas. Okay, so plus hydrogen gas. Okay. Now, if these are our reactants, over on this side, the salt and the hydrogen gas are our products. These are our products. Okay. Now, a salt is when a metal is joined to a non-metal in a reaction between an acid and a metal. So a salt, we can say, is a compound formed when a metal reacts with an acid. Okay, so we've said when a metal is placed in an acid, lots of bubbles are produced. Magnesium reacts vigorously with hydrochloric acid. This is magnesium reacting with hydrochloric acid. The general word equation for this is a metal plus an acid, which are our reactants. We've got our magnesium strip being added to our hydrochloric acid. We'll make a salt and hydrogen gas. And now a salt is a compound formed when a metal reacts with an acid. The gas that you can see in this test tube, or the bubbles that you can see, is hydrogen. Whereas the compound made, the salt made with this, would be magnesium chloride, which we will talk about in a minute. So we can add in red before we move on that the bubbles produced when a metal reacts with an acid are hydrogen gas. Okay, hydrogen gas. So these bubbles that you can see on this image are actually hydrogen gas, and we're going to talk a bit later on how you can test for hydrogen gas. So if we can refresh the screen, remember you can pause it whenever you like. So if you didn't get everything down that you needed, that's okay. You can pause the video and press play when you're ready. I'd like you to put the subheading naming salts. Okay, naming salts. So we can say, and I'm going to put it in red because it's important, the first part of a salt name comes from the metal used in the reactants while the second part of the salt name, in fact we'll put full stop, while the second part of a salt name comes from the acid used in the reactants. The acid used in reactants. Okay, So the first part of a salt's name comes from the metal used, and the second part of a salt's name comes from the acid used. So let's have a think about this before we move on. We can put, we can draw ourselves a little table, and we can put acid used, and in the second column we can put salt name. Okay, so if you use hydrochloric acid, the salt name will have chloride at the end of it. Chloride. If the acid you use is nitric acid, the salt name will have nitrate at the end of it. If the acid you use is sulfuric acid, the salt name will have sulfate at the end of it. So let's see if we can name some salts. Okay, what I'm going to do is I'm going to add this image back in because it's one that we've used. I'm not going to have it as big as it was before. We said earlier that when magnesium reacts with hydrochloric acid, bubbles are produced, and we spoke about the general word equation of when a metal reacts with an acid, and we said that we have a metal, and you have written this down so you haven't got to do it again, a metal plus an acid will always make a salt plus hydrogen gas. Okay, so let's have a think first about this one here. The metal that we have used is magnesium ribbon. So our metal is magnesium. The acid we have used is hydrochloric acid. Hydrochloric acid. Therefore, the salt that we are going to produce, remember we always draw an arrow, not a C equal sign. The salt we're going to produce is magnesium, because that's the metal we've used, and we've used hydrochloric acid, so it's going to be magnesium chloride. So the salt produced would be magnesium chloride. The metal, chloride. The metal produces the first part of the name, and the acid used produces the second part. And then to finish this word equation, we need to add hydrogen gas. I would do it straight like I've done the one up here, it's just I've run out of space. So plus hydrogen gas. Okay, let's have a think about another one. So I'm going to say this time that I'm going to use zinc, and I'm going to add it to nitric acid. Nitric acid. This time, rather than producing magnesium chloride, I would produce zinc, because that is the metal I've used, nitrate, because I've used nitric acid. So zinc nitrate. And I would also have on there hydrogen gas. Oh, no, it's not. It's a plus sign. Apologies. Hydrogen gas. If I start us off with another one, I would like you to have a go at it, please. Pause the video, finish it off, and see if I got it right. If you got it right, even. This time, I want you to add together iron and sulfuric acid. See if you can finish off that word equation. So pause the video now, see if you can finish that word equation for me. Okay, so you should have paused the video. We started our reactants were iron plus sulfuric acid, so our metal is iron, our acid is sulfuric. We're then going to draw an arrow. If you drew an equal sign, you got it wrong. You must always draw an arrow. And our salt is going to be iron sulfate. Sulfate. Because we're taking sulfuric acid and we're turning it into iron sulfate. However, that is not finished. We need to add on the end our hydrogen gas. Hydrogen gas. Okay. So when we're naming salts or writing word equations for when a metal reacts with an acid, we always have the reactants as metal plus acid, arrow, a salt and a hydrogen gas. When we name a salt, the first part of the salt's name comes from the metal used and the second part comes from the acid we've used. If we use hydrochloric acid, the second part of the salt's name will be chloride. If we use nitric acid, the second part of the salt's name will be nitrate. And if we use sulfuric acid, the second part of the salt's name will be sulfate. Now, the only bit we really need to think about now is how we would test for hydrogen gas. Okay, so I've told you that hydrogen gas is produced, but how do we know that? Okay, so I would like you to put the subheading, please. Testing for hydrogen gas. And I'm going to add an image from the PowerPoint that shows exactly how we would test for hydrogen gas, and I can make it a bit bigger. So if you suspect that a test tube contains hydrogen gas, you can add a lit splint to it, you can put a flame inside the test tube, and if it is hydrogen, there will be a squeaky pop. So to test for hydrogen gas, we can say, number one, collect the gas in an empty test tube. Our next step, number two, would be to light a splint. Light a splint. A splint is a wooden stick. We would put the splint, into the test tube. Put splint into test tube. And if you hear a squeaky pop, the gas is hydrogen. So number 4, if you hear a squeaky pop, the gas is hydrogen. So if we are reacting our magnesium strip with hydrochloric acid and we want to make sure that the bubbles produced are hydrogen, we could get an empty test tube, collect the gas, light a splint, put the lit splint into the test tube, and if there is a boop like that, boop, then the gas is hydrogen. Okay? The final thing we need to do, I would like you to write the subheading again, please. Comparing how metals react with acid, dot dot, and I'm going to add an imaging from the PowerPoint again, which looks like this. Now, what this image shows, make it a bit smaller, is 4 test tubes, each containing different metals and hydrochloric acid. We can compare how these metals react by the number of bubbles they produce. So magnesium is the most reactive because it produces the most bubbles of hydrogen gas, whereas lead is the least reactive because it only produces 4 bubbles. Iron and zinc are in the middle, however zinc is more reactive than iron because it produces more bubbles. So we can say that we can compare how vigorously a metal reacts with an acid by counting the number of bubbles produced, full stop. So we can compare how vigorously a metal reacts with an acid by counting the number of bubbles produced. And we can say that magnesium is the most reactive here, as it produces more bubbles. As it produces more bubbles. And we can say that lead produces the least amount of bubbles. Lead produces the least amount of bubbles and is the least reactive. So I could give you 15 different metals, 15 test tubes and some hydrochloric acid. You could place each metal into some hydrochloric acid and you could determine which one is the most reactive by the amount of bubbles it produces. You could make sure which one's the least reactive by the one that produces the least amount of bubbles. So, what I would like you to do now, please, I would like you to pause the video. I would like you to have a go at the questions that are on the board. I would then like you to get a different coloured pen, and I would like you to press play when you're ready to go over the answers. For the first one, copy out the sentences, leaving in the correct word in bold. One of the words is wrong, one of them is correct. For question 2, write out the question before answering it. Pause the video now, make sure you get a different coloured pen and press play when you're ready to go over the answers. Okay, so you should have had a go at these questions by now. You should have a different coloured pen to hand, preferably green, but it doesn't matter what colour really. Let's go over them. So let's add this first one in. I'm just going to cross out the incorrect ones and leave the correct one in. So it should read, some metals react with hydrochloric acid. The products are a salt, so alkali was wrong, and hydrogen gas. Iron reacts more vigorously than lead. Iron reacts more vigorously than lead and less vigorously than magnesium. Some metals, for example, silver, do not react with dilute hydrochloric acid. So it should have read, some metals react with hydrochloric acid. The products are a salt and hydrogen gas. Iron reacts more vigorously than lead and less vigorously than magnesium. Some metals, for example, silver, do not react with dilute hydrochloric acid. Let's have a think about this second question. Oh, no. Let's have a think about this second question. Let's put it up here. And we can put 2A. So 2A says, some breakfast cereals contain small amounts of iron. Iron is an important mineral. Predict the products of the reaction of iron when it reacts with hydrochloric acid in your stomach. Explain your answer. So we could write a word equation for this, couldn't we? And we could say that iron is our metal, hydrochloric acid is our acid. So we can say iron chloride is made. The reason I know this, I haven't got room up here so I'll write it down here, is we could have iron plus hydrochloric acid makes, and remember we draw an arrow, not an equal side, iron chloride and hydrogen gas. So for another mark, not only would we say that iron chloride is made, we would say that hydrogen gas is made. So hydrogen gas is made. And for your third mark, you needed to say that this is because there is a reaction in the stomach. So there is a reaction in the stomach. Our final question, 2B, says describe how you could test if your prediction was correct. You could test the gas with a lit splint, and if there is a squeaky pop, like that, the gas is hydrogen. So if there is a squeaky pop, the gas is hydrogen. So that concludes our lesson today. If we have a look back at our learning objectives, we said at the start of the lesson that you should be able to recall the test for hydrogen gas. Hopefully you can do that now. We said that you should be able to compare the reactions of different metals with acids. You should be able to do that now. And you should be able to use word equations to show the reaction between a metal and an acid. If you have any questions about this lesson, please do not hesitate to contact me. I will get back to you ASAP. Leave a comment in Google Classrooms or send me an email directly. Until the next video, I hope you take care.